This is section 6.1, Algebraic Expressions and Formulas. Let's start by defining variables. Variables are letters that are used to represent numbers. Variables such as x and y are used to represent unknown quantities. Next, we'll define an algebraic expression. It's a combination of variables and numbers using math operations, powers, or roots. Let's look at some examples of algebraic expressions. The first example is x squared plus 6x plus 7. Then we have the example of 6x, 3x plus 5, the square root of x plus 7, and x over 6. All of these are algebraic expressions. What you will notice is these are not equations because they do not have equal signs. There's a big difference between an algebraic expression and an algebraic equation, and students often refer to expressions as equations. However, if there is no equal sign, it's not an equation, it is an algebraic expression. All right, let's talk about how we evaluate an algebraic expression. So evaluating an algebraic expression means to find the value of the expression for given values of the variable. Now always remember to carefully apply the order of operations. Please excuse my dear Aunt Sally. All right, let's look at some examples. We start out with the algebraic expression 6x plus 9, and we want to evaluate it if x equals 12. So what that means is we're going to plug in 12 for x. So we're going to have 6 times 12 plus 9, right? You can use your calculator. 6 times 12 is 72 plus 9, which would be 81. So we've evaluated the expression 6x plus 9, and we've come up with 81 when x equals 12. All right, let's look at our second example. Negative 5x minus 4x minus 11 if x equals negative 1. So let's plug in negative 1 everywhere there's an x. So negative 5 times negative 1 minus 4 times negative 1 minus 11. And again, you can grab your calculator. I'm certainly going to use mine on this one. So negative 5 times negative 1 plus negative 4 times negative 1, and then minus 11, and we end up getting negative 2. So when x equals negative 1, that expression is negative 2. Next we have 6xy if x equals negative 4 and y equals negative 1. So 6 times negative 4 times negative 1. We're plugging in our x and our y values, and we should be able to do this one pretty easily. 6 times negative 4 is negative 24 times negative 1, which would be positive 24. And finally, we have the expression 4x plus 3xy plus 2y if x equals 3 and y equals 2,222. So let's plug in those values. 4 times 3 plus 3 times 3 times 2,222 plus 2 times 2,222. And we'll go ahead and plug that into the calculator. 4 times 3 plus 3 times 2,222 plus 2 times 2,222. And we end up getting 24,454 for that expression when x equals 3 and y equals 2,222. It's very important that students know the difference between evaluating an expression and solving an equation. All right, on this slide we have quite a few vocabulary terms, so let's go ahead and define these. Terms. Parts of an algebraic expression that are separated by addition or subtraction. Coefficient. The number in front of the variable for each term. A constant term is a term consisting of just a number, meaning there's no variable. And like terms, terms with the same variable are like, and constant terms are like. Okay, so let's take a look at some examples here real quick. All right, now before we simplify these expressions, let's go through and understand our previous vocabulary terms. So whenever we look at our first example here, negative 2 times the quantity 4x minus 5, there are some terms here. So 4x and negative 5, so those are two different terms because they're separated by the minus sign. Right? Negative 2 would be called the coefficient of the quantity that's in parentheses. Okay, let's look at our next example, 14x minus 5x. So here we have two terms being separated by the subtraction sign. Our two terms are positive 14x and negative 5x. You have to consider that to be a negative 5x because you could think of that expression as 14x plus negative 5x. So then in that case your terms are separated by an addition symbol. Now if we look at each of those terms separately, 14 is the coefficient of the first term and negative 5 would be the coefficient of the second term. And then we have the expression 13y plus 15 minus 2y minus 11. So we have 1, 2, 3, 4 different terms there, right? And 13 is the coefficient of that term, negative 2 is the coefficient of that term, and 15 is a constant, and negative 11 is a constant. So again, we're trying to help you just understand the vocabulary terms from the previous slide. And I think the other two we can cover as we go through and we simplify. Okay, so let's start with the first one. Negative 2 times the quantity 4x minus 5. We need to simplify this expression, and hopefully you recognize that in order to simplify this, we're going to have to distribute the negative 2 to both terms in parentheses. So negative 2 times 4x would give us negative 8x. And negative 2 times negative 5 would give us a positive 10. So we have negative 8x plus 10, and this is actually simplest form because the negative 8x has a variable with it, and 10 is a constant. So those are not like terms, so we're going to leave them just as they are, and that's our simplified answer. Our next example, 14x minus 5x. As we talked about a minute ago, there are two terms here. You'll notice both of them have an x, so they are like terms, and we can combine them. 14 minus 5 is 9, so we end up with 9x. Right? This would be an example of what we call combining like terms. Our third example, 13y plus 15 minus 2y minus 11. So we talked about previously 13y and negative 2y. Those are two of our terms, and they are like terms because they both have the variable y. So we're going to combine like terms. 13 minus 2 is 11, 11y. Then we have our constants, positive 15 and negative 11. 15 minus 11 is positive 4. So we have 11y plus 4. Next, we have 5 times the quantity, 3x plus 4, minus 4. So the first thing we're going to have to do, remember order of operations, we're going to multiply the 5 times everything in parentheses. So 5 times 3x is 15x. 5 times positive 4 is positive 20. And now we still have the minus 4 that's on the end. And since 20 and our 4, since they're both constants, we're going to combine like terms. So 20 minus 4 will be 16. So we're 15x plus 16. And finally, our last example, 5x minus the quantity 9x minus 17y minus 3. Now this is a tricky one, because notice this subtraction sign. We are subtracting the whole quantity, everything in parentheses, right? So we need to treat this as if there is a 1 here as the coefficient. And we need to distribute the negative 1 to each term in parentheses. This is referred to as distributing the negative sign. So we have our 5x that's out in front. We're going to leave that alone for right now. Negative 1 times 9x would be negative 9x. Negative 1 times negative 17y would be positive 17y. And negative 1 times negative 3 would be positive 3. Now that we've distributed the negative sign, we can look to combine like terms. Well, the only terms that we have here that are going to be like terms are going to be our x terms right here. So 5x minus 9x would give us negative 4x plus 17y plus 3. And that'll be our final answer because none of those terms are like terms. So here are a few more definitions. Equation is two algebraic expressions separated by an equal sign. So I talked about this earlier. The difference between an algebraic expression and an algebraic equation is the equal sign. An equation has an equal sign, an expression does not. A formula is an equation that expresses a relationship between two variables. And a mathematical model is a formula that approximately describes a set of data. So the differences between an equation, a formula, and a mathematical model, there aren't too many differences between the two in terms of how they're represented or what they look like. What is different is really in how they are used. A formula, as it says there, shows a relationship between two variables, and a mathematical model describes a set of data. So this has been section 6.1, algebraic expressions and formulas.